All right, this is part 2 of chapter 3, section 4. We're going to continue on with composition. Okay, so let's scroll down a little bit. All right, so f of g of x. So what I'm going to do here is f of g of x. Okay, so what I'm going to do is I'm going to write the f function. So 3x minus 4, right? So I'm writing the f function first. Okay, and I'm putting inside the g. So the g is x squared minus 2x plus 6, right? So this one is going inside of the f the way it's written. Okay, so if I simplify here, I get 3x squared minus 6x plus 18 minus 4, or thus 3x squared minus 6x plus 14. So that's f of g of x, okay? Versus the other way, g of f of x, okay? I'm going to write the g function first, so x squared minus 2 times the function plus 6. Okay, so now I'm plugging in, the f is going inside, so that's 3x minus 4 and 3x minus 4. So now the f is going inside of g. Okay, so if I do the order of operations, which is exponents first, so I get 3x minus 4 times 3x minus 4 minus 2 times 3x minus 4 plus 6. Okay, I think I'll be a better 3 than that. All right, so we did exponents. Now we'll multiply. So I get 9x squared minus 12x minus 12x plus 16, right? So 9x squared minus 12x minus 12x plus 16 minus 6x plus 8 plus 6. All right, so we did exponents. Now we multiplied. So the final step is to add like terms. So we get 9x squared. Let's see. So minus 12 and minus 12 is minus 24. So minus 6 more is minus 30. Okay. Then we have 16 and 8. So that'll be 24 plus 6 more is 30. So that is our, if I can get it in there, g of f of x. Okay, so what I'm trying to show you here is this is not the same as this, right? They clearly worked out differently. Okay, let's do this in two different ways in the last one. So g of f of 1. So we'll do f of, so that what this really means is g of f of 1. This is what this really means if you rewrite it in the other format. So we'll do f of 1 first. If I plug in 1 into the f, I get 3 times 1 minus 4. Okay, so that gives me negative 1. Okay, so if I plug that into the g function, I'll get negative 1 squared minus 2 times negative 1 plus 6, because that's what g is, right? Okay, so that's going to give me 1 plus 2 plus 6, which is, let's see, that's 8, and that's what, 9? Okay, so that's the first way of thinking of it. The other way is to take this function right here and plug in that 1. So 9 times 1 squared minus 30 times 1 plus 30. Well, the 30 is going to cancel out, and you're left with 9. Okay, so either way, whether you do it in a step-by-step process or use the resulting function, you get the same answer. All right, pause the video, try the student problem for yourself. Okay, so these should be different, correct? So we'll do f of g of x. So that means we're going to take the f function first, so 5 times x plus 6. And we're going to plug in the g, so that's 2x squared minus x minus 1, right? So that means f is going into g. I'm sorry, g is going into f. I said that backwards. All right, so that's 10x squared minus 5x minus 5 plus 6. We'll combine like terms. So you have 10x squared minus 5x plus 1. So that's f of g of x. I got kind of the edge of the board there, so it's kind of freaking out on me a little bit here. So we'll erase it and see if we can fix it up. Went right through it. Okay, let's try the other one. So this is g of f of x. Let's see if I can get the little extra pieces out of there. Okay, so we're going to write the g function, which is 2 times x squared minus x minus 1. So we're going to plug in the f now, which is 5x plus 6. 5x plus 6. Okay, following order of operations, exponents first, so we'll carry out the squared. Okay, now we'll carry out the multiplication. So this is 5x, oh, that's not 5, it's 25. 5 times 5 is 25, right? 25x squared, right? We'll go this way, plus 30x, plus 30x, plus 36, okay? And then minus 5x, right? Minus 5x, minus 6, minus 1. Okay, so equals, we got to distribute one more time. So that parentheses still there, actually. So that's 50x squared, right? So we did exponents, we multiplied them, we have to multiply one more time. Plus 60x, plus 60x, plus 72, minus 5x, minus 6, minus 1. All right, so now we can add terms, right? So exponents multiply, multiply, then the last step is to add. So 50x squared, let's see, 120 minus 5 is 115x. And then 72 minus 1 is 71. Minus 6 more is 65. Here we go. So that's our g of f of x. Okay. All right, so last one, you can do this in one of two ways. One, we can plug it into g first, right, because this is f of g of negative 1. Okay, so that's f of, so if you plug this into g, I get 2 times negative 1 squared minus negative 1 minus 1. Okay, so I get, let's see here, 2 plus 1 minus 1. So I really get f of 2. So I can plug this into f. So that gives me 5 times 2 plus 6. So that's what? 10 plus 6 is 16. Okay, so we plug it in the other one. We should also get 16. We're plugging in what? Negative 1, right? So let's try it out. So we have 50 times negative 1 squared plus 115 times negative 1 plus 65. Okay, so the squared is going to cancel out, right? So that's going to give me a positive 50. That's going to give me a minus 115 and then plus 65, correct? So we really have 50 minus 115 plus 65. Let's see, 50 minus 115 is negative 65 plus 65 is, oh, I plugged it in the wrong one. I'm sorry. That's my mistake. It's got to go in the other one. I'm sorry. So this is 10 times negative 1 squared minus 5 times negative 1 plus 1, right? Because this is the same as this over here. I plugged in the wrong one. I was thinking here. So this is really 10 plus 5 plus 1, which is 16. There we go. We got it. Okay. Let's go to the next page. Okay. So we're going to do domain values of these now. So what thing you have to keep in mind is if you can't plug it into the original, it's not going to be part of the domain for the composition of the function essentially. So in f of g, wherever you can't plug into g also can't, is not going to be the domain applicable. Okay. So let's see here. So we're going to do f of g of x first. So we're going to take the f function and 5 over x minus 1. And we're going to plug in the other function, which is 4 over 3x minus 2. Okay. So we can simplify that if we need to, but I'm not going to. So one thing to keep in mind is this denominator cannot be 0, right? So 3x cannot equal 2, or x cannot equal 2/3. So that is one restriction that we have. The other restriction is this denominator over here, right? This denominator over here can also not equal 0, because again, you can't divide by 0, correct? So essentially, if you think about that one, is 4 over 3x minus 2 minus 1 cannot equal 0, or 4 over 3x minus 2 cannot equal 1. Okay, so if I cross multiply here, I'm going to get 3x minus 2 cannot equal 4, right? So I'm going to cross multiply essentially. All right, so if I add that over, I'm going to get 3x. If I add 2, it's going to give me cannot equal 6. And if I divide by 3, x cannot equal 2. Okay, so I can be any value of the domain of this function. So the domain of this function, the composition, is anything for x except for 2 and 2/3. Okay, so we're going to do negative infinity to 2/3 union 2/3 to 2 union 2 to infinity. Okay, all right. Pause the video. Try the student problem for yourself. Okay, let's make the function first, as you can see it visually. So f of g of x equals, write the f function, so f over x plus 2. So we're plugging in the 1 over x, which is the g of x, right? So the first restriction is that whatever you're plugging into g, that denominator can't be 0, right? Because if there's a restriction on g, there's a restriction on f of g, okay? And then 1 over x plus 2 cannot equal 0, right? Because that's that denominator cannot equal 0. So 1 over x cannot equal negative 2, correct? So what we'll do is I'll put this over 1 so I can cross multiply. So I get negative 2x equals 1, right? So let me cross multiply this way. That's what I'm doing, right? So x cannot equal 1/2 negative, correct? Okay, so my domain can be any value of x except for negative 1/2 and 0. So negative infinity to negative 1/2 union negative 1/2 to 0, and then 0 to infinity. Okay. Okay, and we can just make composition functions into compositions of 2 also, and there's infinite number of functions that can do it. So for example here, the third root of x squared plus 1, there's a variety of answers for f of g. So f, whoops, let me turn my pen on. Come on, pen. Okay, f could have been the third root of x, and g could have been x squared plus 1. So if you put in g into f, you'll get the resultant h of x function essentially, right? All right, so pause the video, try the student problem for yourself. Okay, so f of x could have been the square root of x, and then g of x could have been x plus 5, right? Because you're taking this, putting it into there, and it becomes the new h of x function. All right, that is the end of part 2.